Hello traders and developers, I'm Lenny Kirudu, a PineScript developer with over 3.5 years of experience working with numerous freelance clients and creating popular open source indicators used throughout the trading community. In today's video, I'm kicking off a comprehensive series that will break down every key concept in PineScript, from fundamental data structures to advanced topics like tables, alerts, timeframes, and strategy development. So how am I creating this series? Two key reasons. First, I want to strengthen my connection with the trading and PineScript community, sharing ideas, exchanging ideas, and fostering meaningful discussions that help us all grow. Secondly, as I expand my focus into quantitative finance with Python, I want to maintain my presence in the PineScript ecosystem that's been so rewarding over the years. And truthfully, I genuinely enjoy making educational content that helps everyone grow. So whether you're just starting your PineScript journey, you're an experienced coder looking for quick insights, or you're a trader wanting to automate your own strategies, this series has something valuable for you. I'll be sharing practical examples, insider tips, and best practices I've developed through the years of real-world application. Let's dive in and explore the powerful world of PineScript together. So this video is divided into two main parts. In the first part, I'll break down some core theoretical concepts essential for understanding PineScript and the TradingView environment, including the execution model and the idea of a time series. In the second part, I'll walk you through PineScript code step by step, starting with the fundamental concepts like variables and built-in functions, and moving on to more advanced topics such as user-defined functions, objects, and enumerations. Chapters are included so you can easily skip ahead to the section you're most interested in. PineScript is a domain-specific language created by TradingView, designed exclusively for developing indicators, strategies, libraries, and alert-based systems within the TradingView platform. Now, what does domain-specific mean? Unlike general-purpose languages like Python, which can be used for everything from web development to data science and machine learning, a domain-specific language is built to serve a particular purpose. In this case, financial market analysis and trading automation. PineScript is optimized for handling historical and real-time market data, allowing traders to easily create custom indicators, automate signals, and backtest strategies directly on TradingView charts. It operates in a bar-by-bar execution model, meaning each script runs once per bar, processing price and volume data as new candles form. It shares similarities with other programming languages in terms of logic and functions. However, PineScript has unique limitations such as no direct access to external APIs or databases and a sandbox execution environment, meaning it can only interact with TradingView's internal data. However, its simplicity and ease of use makes it incredibly powerful for traders who want to customize their trading tools without needing extensive programming expertise. PineScript operates on a bar-by-bar execution model, processing each candlestick sequentially as it forms. This fundamental approach determines how your script behaves across both historical data and real-time market conditions, directly impacting indicator reliability and strategy performance. When processing historical data, PineScript executes precisely once per bar, utilizes complete price information, that is open, high, close, low, and volume data, performs calculations with perfect hindsight, and maintains consistency across executions. During live market conditions, PineScript executes continuously on every price update, works with incomplete evolving data until bar closure, recalculates indicators and signals dynamically, and may produce different results than historical calculations. PineScript employs a critical rollback mechanism during real-time execution. When a new price update occurs, the script reverts to a clean state, where all user-defined variables are reset to their declared initial values. This is key when initializing variables. Previously done elements, such as labels, lines, and tables, are cleared and calculations restart, using only data available at that moment. Essentially, no memory of previous calculations within the current bar is maintained. This rollback process ensures calculation integrity, but creates challenges for developers tracking intra-bar state changes. Lastly, repainting occurs when indicators or signals appear perfect in hindsight, but will have displayed differently during live trading. This discrepancy emerges from calculations based on incomplete real-time data, mid-bar signal changes, and during price fluctuations and using future data inadvertently in calculations. So that's just an overview of what the execution model is and how it affects scripts in historical and real-time information. It's important to practice these concepts in code to actually understand them, as we shall do in the second part of this video. In PineScript, a time series is a fundamental data structure used to represent the evolution of a variable over time. Each value in a time series corresponds to a specific point in time. typically one for every chart bar, making it ideal for real-time market analysis and trading decisions. Unlike arrays, which are a general purpose structure, storing values in a sequential order, time series data is inherently tied to the chart's timeline. Each element in a time series reflects the value of a variable at a specific historical or real-time bar. PineScript is designed to automatically handle this chronological data structure, allowing developers to access previous values using built-in references without writing explicit loops, as we shall see in the coding part of this video. This implicit handling of historical data makes PineScript highly efficient. Many operations that would normally require iteration, such as calculating indicators, checking for conditions over time, or reacting to price changes, can be in a single line using time series logic. This not only simplifies the code, but also enhances performance, making time series a powerful tool for building responsive real-time trading algorithms. Okay, so in this next part, I'd like to introduce you to the user manual and the reference manual. So I'll just slightly go through this. So this is the user manual, which is the corpus of information that is PineScript. It's the base documentation of the language that has all the information on the language here. This is the actual data structures the language has, and the coding structure that's typically used, and the execution model and the time series. I won't be going through the documentation in this video, but it's important that you use these in your learning process or in your coding process. And we also have another important section called concepts, where it discusses the things you can actually do with the language, such as creating alerts, creating strategies, creating tables, and dealing with timeframes and all these kinds of things. So this is what the language is mostly used for. So again, this is the user manual, and it can be accessed. Let me just open the chat, because you typically find yourself in a situation like this. So with the chat open like this, you'd come down here and open the panel, where you'll have these tabs at your disposal. We shall be focusing on the Pine editor in this video, and in the next video we shall look at the strategy tester. So if you come here to these three dots, go down to help, you will find Pine references, where you have the user manual, which is the documentation I'll show you right now, that holds the corpus of information that is PineScript. It's very important to go through this thoroughly if you're really interested in mastering PineScript, or if you just want to make really advanced trading systems for yourself. Secondly, we have what we call the PineScript reference manual. So you can come and access this the same way. However, this will appear directly on your chart as is. And this holds the built-in variables and the built-in functions that the PineScript, the TradingView community has developed for efficient PineScript developing. So these are the inbuilt functions and inbuilt variables that you'll use on a day-to-day basis while coding any PineScript indicator or strategy. So there are a lot of them, and you'd have to go through them over a long time to really understand what everything really is here. However, in this video, I will try and give you a little description of how they can be used, and hopefully you will be able to build an intuition for how you can use them yourself. Another way to access the reference manual when you're coding directly in the Pine editor is to come anywhere in the script here, is to go anywhere in the script you're working on and press Control and the left mouse button, and it's going to open up the reference manual with the item you're hovering over highlighted. For example, this close, which is a built-in variable. If I do that, it takes me to the close section of the reference manual, and you can read that close price of the current bar when it has closed or last traded price over yet incomplete real-time bar. So let's move over to the interesting part of this video, where we'll actually be coding an indicator. So we'll create a market structure indicator, which creates pivot points, such as the higher highs and higher lows, and lower highs and lower lows, to identify uptrends and downtrends, in price action. So I'll start the indicator pretty basically, mostly working with variables, operations, some built-in functions and built-in variables, and if statements, which are conditional statements. And then as the video progresses, I'll move to create. I'll add functionality to the script by adding user-defined functions to reuse the code, and then we'll move on to make the code easier to interpret by adding things like objects and maps. And at the end of the video, we shall add an enumeration to the script just to see how it works. So that by the end of this video, you can have an understanding of what the PineScript language entails and its basic data structures, aside from the time series data structure that we discussed in the theoretical part of this video. So in PineScript, identifiers are the names assigned to variables, functions, and custom inputs. For example, my variable is an identifier used to store and reference a value throughout the script. So you can create a variable such as my variable that stores the value 0.0. And there are multiple ways to initialize this variable. You can have it initialize as is with just the tag my variable, which is the name of the variable itself, it's identifier. But because of the nature of PineScript, the time series nature of PineScript, where we use the execution model that executes the PineScript on a bar-by-bar basis, this variable will be reinitialized to the value 0.0 on each new bar. So whenever a new bar is created on the chart, the variable, my variable, will be reset to 0.0. So if you don't want that to happen, you come here and add the keyword var before my variable. So what this does is it initializes the value my variable to 0.0 at the first bar. Essentially, when, let me just write this out very quickly. So when using var, my variable will be set to 0.0 on bar index is equals to 0. So what that means is when the bar index, which is a built-in variable that stores the sequential number of the bars on the chart, is equals to 0, which means it's the very first bar in the time series. So essentially the leftmost bar on the chart, the very first bar on this time series index here is 0. It's the first bar in that series. And as we progress across the time series towards your right until the real time bar, each bar adds 1 to the bar index. So the current bar is the current bar index, and the first bar is bar index 0. So when you declare a variable using the var keyword, it's set on the first bar and can only be replaced if this variable is dynamically replaced inside a conditional statement. So with var, it's as we go on in this video, I'll try and use var, and I'll try and use variables with var and variables without var more often so that you can get an intuition of what I'm trying to explain. But just to cap it off, var saves memory. It creates memory for the variable. And without using var, there is no memory for the variable, and it gets rewritten each time a new bar is formed. We have another way to initialize variables using the command varip, but varip is used for intra-bar changes. So when we have a new bar, such as the current bar here in price, whenever a new tick is formed or new data is accessed, varip stores that information. But in this video, we shall focus on using var and no var, essentially. So we have other operations in PineScript, such as arithmetic operations, such as plus, minus, multiplication, and division. We have comparison operations, such as greater than, less than, equal to, and not equal to. And we have logical operations, such as and, or not. These are the building blocks for most expressions and conditions in a script. So now let me just move into some actual coding. So first, let me create. So for starters, maybe I should start off by showing you exactly what it is we are creating. So I lost my camera feed for a minute there. So So let me first show you an image of what it is we are going to be creating. So let me just write maybe higher high, maybe higher high, higher low, lower high, and lower low. Maybe it's going to give me a really good. Yep. So this is exactly what you're going to be creating, a pretty common idea in price action trading nowadays. So I think it's pretty ideal for this video. So this is essentially it. We're going to be creating this market structure price action tool that identifies these pivots and identifies where they've happened in a chronological order so that it can create the right references for the higher high, the higher low, the higher high, the higher low, and the lower high, lower low, lower high, lower low. So now let's move into the actual code. So let's start by making a user input that will allow us or any user to access the script and to make some slight modifications. So this is how you create an input. You use the input.int, .float, .string. There are multiple variations of that. You can access them by going into the user manual, and you can see them here. So input.int means we are accessing an integer value, which is 1, 10, -1, -50 without any decimal values to it. So we'll set this to 10 and title. So this is a title that the user will see when accessing this indicator. So variables to identify. Writing comments is pretty important because you'll need to go through this code again, and you might not remember exactly what functionality you created to do what you did. So let me just write this here. We initialize the variables with var, that is var index is equals to 0 to give them memory. So we initialize the variables with var, that is on bar index 0, 1 to give them persistent memory. And let me just add, and not to have them been rewritten on each bar. So that's the only point of using the var keyword, right? So these are some necessary variables that we'll need. To store the previous highs and the previous lows so that it can understand the sequential nature of the new highs and the new lows being formed. So I'll explain more of that as we proceed with the script. And then let's make variables for market structure. So we have higher high. So I'm setting this to false. Essentially, I've made these variables Boolean variables by giving them a value that is Boolean in nature, true or false. The same way I've made these ones float values by initializing them with a float value at the start. So you're gonna make 4 of these. So you're gonna have the higher high, and then you're gonna have the higher high, and then you're gonna have the higher low, and then we're gonna have the lower high and the lower low. Okay, let's carry on. Next, we shall use something called built-in functions. These are functions and variables defined by the PineScript or the TradingView community that rely on the time series nature of the platform and everything to create these snippets of code that you don't need to rewrite every time, and they do a good margin of the work for you. So to calculate local highs, so we're going to calculate local highs and local lows. So we're going to calculate these local highs and local lows. Sorry about that. Okay. So I'm going to name this tf.sh, which stands for timeframe_sh. The sh stands for swing high, tf stands for timeframe. As you can see, I haven't initialized this variable with var, so it's going to be written on each candle. And that's important because this is a calculation we are doing in this next part. So da.pivot high dot now swing length. So ta.pivot high is a built-in function defined by the PineScript community that calculates local highs and local lows by taking in a value such as 10 in this case, which is the swing length value that we inputted here. And whenever a new candle is formed, or on any candle on the bar on the chart, it looks 10 candles to its left and 10 candles to its right, and checks whether that candle is the highest candle within that range. If it is, that candle's high value, specifically its high value, is stored inside the consistently changing variable tf_sh. Then we have tf_sl, which now calculates the local low value. So essentially, any candle looks 10 candles to its left, 10 candles to its right, and checks whether that candle is the lowest candle within that local scope. So that's how we're identifying these highs and lows. And then we're going to go and ahead and store their values in this variable later on in the script so that we can compare whether we are making consistent higher highs, consistent higher lows, consistent lower lows, and all that. So this is all important data to carry on with the script itself. Okay, so next we'll check whether we are storing a value. So NA is another built-in function created by the TradingView team. So if you access the reference manual and come here, you'll see NA returns true if X, which is the variable passed into it, is NA, false otherwise. So if the value passed inside NA is not available, then it returns true. And if there's a value inside this variable tf_sh, it returns false. So essentially, it checks whether there's a value inside tf_sh, and if there is, it returns false. So we add this not, which is a conditional operator, before this statement to make it return true if there's a value inside tf_sh. So it's a pretty neat technique that can help you when coding these things. So if there's a value in tf_sh, meaning we've identified a new local high, we set the value higher high to okay, this should be. So we set the value higher high, which was set to false here, to true if the value inside here, which is the new local high that we've discovered, is greater than or equal to the previous high, right? And to make this come full circle, we'll also need to do this timeframe_sh. So whenever a new local high is identified, its value is stored inside the persistent variable timeframe_previous_high. So now, when a new pivot high is identified, we can check whether that high's value is greater than the previous high that had been identified by the same pivot high function. And that's how we create this idea of identifying the highs and the lows, right? So higher low is not higher high. So what that means is, if we identify a new high, but it isn't greater than the previous high, then it's a higher low. So essentially, this is how we create the true state for this variable higher low. So, okay. Now, let me visualize this on the chart to make it more understandable. So label new is a built-in function created by TradingView. Let me just use time.swing length y timeframe_sh and text just to So as you can see, I'm using a lot of inbuilt things. We shall give it time frame underscore sh. So assuming the Cartesian plane, x is the time value. So x is the time value and y is the price value. So we're identifying a point on this axis that meets these two coordinates. So let me just save this. Let me just save it by pressing Control S, and then I'm going to name it YouTube script 001. And then after saving it, I'm going to add it to the chat. Okay. So that can't work. Okay. So a couple of issues need to be fixed. First, this needs to be set to overlay is equals to true. So overlay is equals to true plots your indicator on the actual chart. When it's not set to true, it will display down here in something called pen mode. And then here for the label new, because we defined x as time, we also have to initialize this variable as a bar index, a bar time state. So it understands that it's using time to draw this plot on the chart and not using bar index. Let's save that. So now let's add it to the chart and see whether it identifies the higher highs. So as you can see, it does identify local highs. As you can see, it's identifying some nice local highs, right? So those are the higher highs as of now. Okay, so sorry, I'm having some latency issues with the camera, but as long as the audio is okay, that shouldn't be an issue. Okay, so now let me build up the rest of this functionality. Okay, so else, now let's just copy this here. Now this is to identify the higher lows, because if higher high, then so if the higher high condition is set to true, if it's false, the higher low condition is true. So let's this is all correct. Yeah, this is all correct. And we've set the previous high value to the swing high value. So we just need to replicate this so that we can do the same thing for the higher lows, for the lower high and the lower low. So here we should change this to lower high and lower low. And so lower high is true if the swing low value is greater than or equals to the time frame previous low, and this is set to true if that isn't the case in that department. We come here, set that to lower high. We should change these values here to swing low, swing low, swing low, swing low, swing low as well here, and then now we set this to previous low and we save that. So once saved, you can observe what it's doing on the chart. So it's kind of messy because we can tell what is what. So let's just go back into the script here and let's change these values from that to values we can better see on the chart. Change this here to higher low. Let's change this here to lower high. And let's change this here to lower low. And then we can add some styling the scripts to be able to see them better. Label, I'm looking for label up. Sorry about that. I'm looking for label label dot style label up. So it's a styling technique to differentiate our different plots, and maybe we can even change its color just to make it more readable on the chart. So this is all readability. Let me just save that and see how it's going to respond. Yeah, and there we have it. We have it identifying the lower highs and the lower lows properly, and the higher highs and the higher lows. So because of visualizing on the chart, now you can see some logical errors. This should be higher high, then this should be higher low, then this should be lower high, and then this should be this lower low should be accurate. So need to change some things to make it actually make sense according to how the indicator logic should be structured. So we should change this here to lower high. So this is why visualizing on the chart is key, because it allows you to actually see what your script's logic is actually doing, and you can be able to tell whether it's performing as it should. So high, low, hello, hello. So this is checking the lows, this is checking the highs. So let's run that. Yeah, and you can see you have better structure. You have higher high, lower high, then you have a lower high. No. This should be lower high, and this here should be higher low. Again, visualizing on the chart is actually a very important skill while dealing with making systems, indicators, or strategies, because it allows you to quickly see what's going wrong with your script, right? So yeah, so now we have some better logic on the charts there. Yes. So we have better logic on the chart, and now we can move on to different section of the script. So just to recap, we've used this basic function with a few variables to declare the var variable, this one that's written on each bar, to create the function that identifies pivot highs and pivot lows as we go along the time series order of the chart, and create all those pivots. Now we can move on to a different section of the video where we'll be looking at built-ins and user-defined functions. So in PenScript, built-in functions and variables offer essential tools for accessing market data and performing common calculations. For example, functions like ta.pivothigh, which you use to calculate those pivots, which without using this inbuilt function would require us to maybe even write loops to go through all those candles, saving the value of the highest one and its count so that we can identify where it is in that local scope. So built-in functions are really powerful because they give us the ability to circumnavigate that. This allows us to compute technical indicators such as that, and even the 20-period simple moving average, which can be calculated by something as simple as this, which I'll show more of in the video, which allows you to create. So this essentially creates a 20-period simple moving average, which is essentially the average of the last 20 bars consistently calculated across the chart as a line or as a series. And you don't have to recalculate this every time you need to use it. You just call ta.sma or even ta.ema for the exponential moving average. And then we have other built-in variables such as open, high, low, time, bar index that allow you to reference values on the chart. For example, writing time with the swing length input here gets us the time 10 candles back, because as we discussed, ta_sh identifies a point to be the highest or the lowest in a range once we've gotten information from 10 bars to its right and 10 bars to its left. So we have to wait for 10 bars on its right to close. Then we can identify that 10 bars back was the high or the low, right? So we also need the time 10 bars back. So that's why we put time and swing length here because we are referencing that time back. And this can be done with multiple things. For example, let me just give you a really quick example. If bar state is last, which is another built-in that allows you to identify whether the current bar on the chart is the last bar, you can come here and do label.new, and then we're gonna set x to bar index. Let's do 20, and close. Let's also do 20, and then let's add a text to help us see it better. Text to string, and let's do close 20. And let me just save this and show you what it means to use this built-in variables like this. So if the bar, on this last index here, so if bar state is last, it identifies the last bar, and then we've set this 20 bars back. So as you can see, then it's right here, 20 bars back. We've been able to identify the bar index, which is 20 bars back, and the close 20 bars back. However, it's not very visible. So maybe what we can do is maybe we can do this. Close and bar index. It's going to plot on this bar, but it will tell us the close 20 bars back. But let me just do something that's a bit more visible, like this here, which is 7 bars back. I'm just trying to show you that these built-in variables allow us to access information pretty easily. So let's see whether that's the actual high. So we can use, so we can create a line, a horizontal line, come here and input that value 1.3729. And as you can see, it's identified this close up here. And if you come and use this tool, you can see that is exactly 7 bars back. So that's just a quick example to show you how the built-in functions and variables give you access to market data in real time and historical time without you having to do too much. We also have time functions like year, month, day for working with calendar-based logic, and bar tracking, which we've already discussed, such as the bar index. To go beyond built-in capabilities, PineScript allows the creation of user-defined functions, which is a very common idea in almost all programming languages, enabling you to encapsulate custom logic into reusable blocks of code. These functions help organize scripts. Reduce repetition, and make your indicators or strategies more modular and maintainable. So let me just show you really quickly how we can take all this, make it a function, and then reuse it to do the same thing again, right? So I'm just going to name this market structure. You want to have all this inside it. And this is how you define a function. So this is the syntax for defining a function. And then now you have to indent this information. Now now let me add a parameter, string length, right? And then I'm gonna change this to string length _1. And now _1 will do the exact same thing. So you want to have these variables inside here because they are part of this functionality, so you don't have to rewrite them outside. And if they're outside this scope, they can't be changed inside the scope. They are immutable inside the scope. So if I was to come here, you can see nothing has changed. We still have the same information on the chart. Now, what I'm going to do is I'm going to add another parameter called color with an underscore at the end so that we don't confuse with the actual color parameter. And then I'll come here, add color to all these elements so that we can distinguish once we call the function again. So there we go. And there we go. So I'm going to call this first one with the color as green. So all the plots will be green for this. And then we'll call this function twice now. And then we'll name this one red. And then we'll create another input. I'll show you how this I'll show you how this input looks like on the chart. And we'll give this one a string length value of 50. Then let's save that. Actually, let me just add something here. Max labels count, because it's going to limit the number of plots we can have on the chart. So I'm gonna make them 500 of them, essentially. And then if you come here to the chart, you can see the red ones are defined by a greater swing length point, 50 bars. It's using 50 bars on the right, 50 bars on the left. And the green ones are using 10 bars on the left and 10 bars on the right to identify their individual points. And you can come here and manually change this in the input. If I was to set this as 10, they would all mesh into the same exact points. And if I set the green one to 50, we get this nice reversal of what we had at the start. And that's why functions, user-defined functions, are important, because you can reuse the same code to do the same thing without writing it over and over again. So now I'm going to introduce you to the idea of arrays and objects. So what I'm going to do is I'm going to take you through the theoretical concept that is arrays, and then I'll introduce you to the theoretical concept of objects, and then I'll create some code to show you how the arrays actually function, and then how objects make that functionality easier to deal with, essentially. So let me jump into that. So arrays are a specialized one-dimensional data structure used to store indexed elements of the same type. PineScript uses built-in methods such as arrayGet to retrieve values and arraySet to modify them. Arrays are declared using arrayNew.type, and when combined with the var keyword, they are initialized only once on the first bar, similarly to how we initialize the variables using var. Without var, the array is reinitialized on every bar, which can lead to performance issues or unintended behavior. Looping through arrays is a common practice, especially for tasks involving historical data or custom calculations. The method array.size, which is another built-in function created by TradingView, returns the current number of elements, which helps in determining the maximum index for iteration. Notably, global arrays can be accessed and modified within local scopes, meaning you can create an array outside of this function and still be able to modify it inside the function, unlike variables. And you can dynamically modify arrays using a wide range of built-in functions, such as inserting elements into an array using array.push and array.insert, and removing elements using array.pop, array.remove, array.shift, and array.clear. These functions make it easy to implement classic data structures such as stacks, which is last in, first out, using array.push and array.pop, and queues, which is first in, first out, using array.push and array.shift. In addition, arrays support operations such as concatenation, copying, joining, sorting, reversing, and slicing, and also searching, making them powerful tools for managing dynamic datasets and indicators and strategies. So essentially, arrays are a common data structure, quite similar to time series data structure in TradingView. However, each element is not tethered to a time variable on the chart, and they can be stored sequentially, even bars apart. So when a condition is met, you can store a specific value, and that's where the advantage comes in when using arrays of a time series, because it's not tethered to each specific bar. They can be bars apart, and you can store the close value only when a new pivot high is discovered, and it's not tethered to each bar across the time series, essentially. So I'll show you some code after I've explained the idea of objects, just to make everything a bit quicker and a bit easier to understand. So UDTs in PineScript function similarly to classes in other programming languages, but with a key distinction. They are data containers without methods. So that means they don't have functions inside these classes, and all they do is just store data types. Traditionally, with a language like Python, you would have the class having the information as well as the functions inside it that work on the data, right? And those functions inside those classes are called methods. But here in PineScript, the classes don't have methods inside them, and they're called UDTs. So you can think of them as structured records or methodless classes that group related data fields together under a single name. And you'll see why this becomes important as we carry on. So to create a UDT, use the type keyword followed by the type. You use the type keyword followed by your type name and a collection of typed fields. So let me just start off with the object, and then we'll create some arrays. We'll store information in those arrays, and then now we'll create a object of arrays essentially, and show you how it simplifies the process of using arrays and using data types in PineScript essentially. So let's create a type or an object or a methodless class. It goes by many names by using the word type, and then we're going to name it pivot point, right? So that's how you create a type, by initializing the word type in front. And then now you create the variables inside it, and you declare what type of variable they are. So int x, which is this value, it's this value that we are trying to store. The x value that we've used to plot these higher highs and higher lows on the chart. And float is for this value, so y is going to be float. And then let's add string. String value is essentially like characters, words, and such things like those. So for this, we'll name it label text, which is going to be this text here. And lastly, string xlog is equals to xlog dot bar time. So by giving this a defined language, we make it like a default for our type. And when we create a new instance of this type, we don't have to redefine this variable xlog as xlog dot bar underscore time. We don't have to reinitialize this every time now, since we've set it as the default inside the type that we'll use to call these values or create these plots, as I'll show you right now. So what we'll do inside this function, we'll create instances of the type we've created that we shall then manipulate later on inside the script. So I'm going to name this high object and set it to an instance of our type by calling the type that is pivot point dot new. So that makes an instance of the class, and as you can see, it's given us the data types that are inside the class to assign them values. Now we can now assign them values, but for now we are just going to create the object. So that is high, and then we're gonna do the lower high object, and then we're gonna do the higher low object, and then lastly you're gonna do the lower low object. So here we're gonna remove this label for now, and if high, we're gonna use this operation that essentially rewrites the value inside a variable such as this. And now what you're gonna do is you're gonna call pivot point brackets, and we're gonna assign a value to each of the elements. So for x, we're going to assign this value here. For y, we're gonna assign this value here. And we're going to assign high as the text value. You don't have to initialize this. Oh yeah, so yeah, this should be pivot point dot new. Sorry about that, not pivot point. It should be pivot point dot new, and we don't have to call xlog again because it's already been defined in the previous inside the type itself, and that's a default value now. And now we can do label dot new, and then x is going to be high object dot x. Y is going to be high object dot y. So as you can see, we're just sourcing the values from the object that we made, that is high object, and then high object dot label text, right? So it makes accessing these values easier. You can see we've already kind of created a way to access these values just by using the type keyword. So that's how it's done. So we can repeat this process for all of them. Just copy and pasting makes life easier. I can come and name this lower high object. As you can see, I don't have to change anything except this here. Come and change this to that, lower high. And now when I do this, it's the same functionality, right? So let's just copy and paste them for all of them. And then this one as well. And this one as well. Comment out the previous label. And then this becomes SL. And this is high low. This here should be low high. So this is higher low. This is lower low. This is string low, right? And all you need to do is come and make sure this is set correctly to the right object, and just replace those values. Lower, lower. So this is just to show you. This is just to show you. So I have an error. 500 bars in the future. 71. Okay. That shouldn't be happening. So the error is at 62. Okay, so maybe what the issue is, hello object dot xlog. Maybe I just need to add this default value to all of them to get rid of this error. Let's see how that works. Yep, that seems to have been the issue. So as you can see, the plots are appearing in the chart. They don't look the same way they did. So we can just add the styling tips. We can leave this as the same. Maybe just add the color concept and save it. And it should look exactly how it did before. So that was just to introduce you to the idea of how objects are. They're just a way of writing script that is more efficient and more readable. So it's easier to see what this pivot point that is creating all 4 pivot points is storing in one place, and be like, oh, so it's just these values. It's a time-based plot, and it just makes essentially, it makes code more readable, especially when you're dealing with it in the future, or when you give it to someone else to process it for you, or someone you're working with, right? And now I'd like to show you the benefits of using these kinds of things I'd like to show you the benefits of using objects by introducing arrays and showing you how the arrays can store information and how the object can store that same information, but easier. Essentially is what I want to do in this next part. So let me create the arrays for starters. So what I'm going to do is I'm going to create the arrays inside the function, and then the function at the end is going to return the arrays for these two instances of the function that we are calling, right? So let's define the arrays inside. Let's maybe comment this first. These are variables. No, these are pivot point variables. Pivot point variables. Let's jump a couple and name this array variables for individual elements. Remember, using the keyword that makes it persistent and have memory. So float is just another way of initializing variables by telling the variable identifier, when you call a variable, you're telling it what type it's going to be using. So when you write that, now it knows it's going to be storing float values. So float is a way, writing this is a way of initializing an array by telling it it's going to be storing float variables. So pivot prices is equals to array dot new underscore float. So that's how this is how arrays are declared in PineScript. And this 0 here means its size is 0. It has no elements inside it right now, and I haven't given it any initial value to start with. So I'm going to replicate this a couple of times. I'm going to change this to int and change this from pivot prices to pivot times. And this is an integer based array. Okay. And then we have pivot types, which is going to store string values, which are this higher, lower, high pivot types. Yeah. String. Which essentially just store the higher, low, high text. Yeah, and that's how you declare arrays. Again, you don't have to write this. This was just me. You don't have to write all of this. You can have it like that and still work the same way, because you've still declared it here as float, int, and string. But let me just leave it like this to maybe help make it easier. And then now you're gonna store values. You're gonna store values in these arrays. So if we have a new pivot high, we're gonna store its value. Okay. So for starters, we won't plot inside the function anymore. So let me just now we're going to use arrays to do this. So as you can see, I'm just trying to teach you how to use all these different elements to code with. So we're gonna add we're going to add so we're going to add the elements to the array using array push. So if you just come here, control control and left mouse button, it opens up the reference manual, and you can see this function appends a value to an array. So it adds the value to the end of the array. So you have an array with 5 values, 1, 2, 3, 4, 5, and then you add the value number 6. It adds it at the end, so it becomes 1, 2, 3, 4, 5, 6. You can also use array.insert, which adds elements at the start of the array. So if you had an array with values 1, 2, 3, 4, 5, and did array insert, it would add the element number 6 at the start of the array, and you'd have 6. And you'd have 6, 1, 2, 3, 4, 5. So let's do array push. So let's do array push pivot prices. And this is time frame string high. And let's replicate this. And let's do pivot times and pivot types. So pivot time is time, swing length, and for pivot high we have if higher high is true, then it's going to store higher high. Else, so this is a quick way of doing an if else kind of statement. So this is like saying if higher high, then save the string as higher high, else save it as lower high. So it's just like a quick inline if else statement, which is common in some programming languages. So we'll do that, and then we'll do the same thing here. Same arrays. We're not going to use different arrays. We saved the swing low now, and higher low. We save higher low and lower low, and then lastly we have to return these elements. We need to return these array elements. What we're gonna do is create this at the bottom. And pivot types. So we'll get an error here because these two aren't returning the values. If we were to run this, we'd get an error here because it's not going to return any of these three values. So we need to come here, boom, goes to that, goes to that. And now we've assigned these values. We've assigned three arrays to the output of this. To the output of these functions, and we can just give them unique values individually. Right, so as you can see, we aren't plotting inside the function anymore. We are now extracting the values inside the function using arrays. We're just storing the values inside the arrays, and then now calling the functions with the three arrays we've created. So now they have the individual values themselves. So let's now loop through these arrays, because that's how you access elements in an array. You access them via looping through it and plot the last 20 elements on the chart. So the first step in looping through arrays is to check the array size. For example, let's do for this one, because all these three elements will all have the same number of elements, these three arrays. So this array size checks the number of elements inside an array. It gives you the count of the number of elements inside an array, and we check if it's greater than 0 to make sure that we're actually dealing with an array with information. If you don't do this, you normally get an error. So it's just customary to do this. And then calculate starting index for only the last, let's say 10 elements or fewer, could be fewer. So start index. So you're creating the index so that we can loop through these things. Use math. Because I'm doing this because I only want to, I don't loop through the entire array. I just want to loop through the last 10 elements. Pivot. There, start index. This is going to make looping through them a bit easier, so you don't have to. So this is going to make looping a bit easier, so you don't have to go through everything. Y is equals to start index to array size. Array size. Let's see. You have to use the same array. -1. We're going to do -1 here because indexing normally starts at 0 in, I'm guessing, all programming languages, or most of them. Indexing starts at 0. Yes, indexing starts at, so in most programming languages, indexing starts at 0. So subtracting 1 shifts the count we're using by 1 value back because it's going to start at 0, right? So let's do that. Indent, whenever I use if statements or for loops, we should indent, very similar to Python. So let's get the y value. Now we are going to retrieve the y value, and we're going to use array.get. Now here we don't use indexing like with the time series data structure, where we just did time 10, close 10. So you can just do, you can just get the value by doing pivot price, then the square brackets 10. It will give you that. It doesn't work like that in this because we don't have a sequential order of information on every single bar. So it's not that easy because the conditions can happen at odd bars apart. Could be 7, then 2, then 19. So here we use the array get function, pivot price _1, and then I meant I for the looping, for the value you're using to loop through. And then we're going to replicate this. As again, copy and pasting makes your life easier as a developer. You don't have to write everything all the time. Private 1, 2. So now for xval, now we use times. 10 times, yes. Remember, those three elements, those three arrays have the same number of elements inside them, right? And then now what you're going to do is you're going to plot, sorry about that, is you're going to plot the label now using this new method we're using here. Is equals to yval, text is equals to textval, xlock is equals to xlock dot bar time. Remember here we're not using the type, so we can just call xlock dot xlock dot from the type itself. And then style we'll use textval. If textval is equals to yes. So if textval is equals to low, or textval is equals to higher low, we'll set it to label.style underscore label. Isn't it giving me what I want? Label up. Else we'll use the default style label underscore down, right? And yes, this will now plot. This should be equals to. This is a symbol for equals to. It's two equal signs together. Textval. Okay, simple error. Big part of developing is actually debugging. So if you go down this line, you'll probably have to get used to going through code and debugging it a lot more often. So 95. Around index 1 is out of bounds, array size is 1. Oh yes, for me to get a start index that is 10 bars back, I need to get the max value between 0 and the array size 10 bars back. So let me add And here, let's see if that's going to fix the issue. Yeah. Okay. So we're trying to loop only through 10 elements. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It might be a bit more. So adding -10 here makes our start index work a bit more efficiently and clears the error because it creates the optimal starting point. If we have less than 10 values, it just starts looping from the first element. And if we have less than 10 values, it just starts looping from the first element. If we have more than 10 values, it starts looping from somewhere around 10 values back, giving us less to go through when we are plotting this, because we don't need to plot too much to understand what we're doing here. And so, yeah, adding -10 here, subtracting 10 here clears that error because of that. And now we have it. Now we've stopped plotting inside the function now. And what we're doing now is we are storing these individual elements inside these individual arrays. And then now we are looping through one of the arrays because they all have the same size and replotting them. So I just wanted to show you how storing information inside arrays actually works. And yeah, there we have it. And now we can actually just get rid of this. Yeah, so I just wanted to introduce you to that idea. And now what we're going to do is we're going to stop using 3 individual arrays. We're going to use an object of those arrays. We're going to use those arrays as objects to make things easier, right? So now let me show you what I meant when I said that that those objects make coding more readable. Object. We're going to name this var pivot point. Pivot is equals to array.new. Array.new. Then this is how we declare it. Pivot point. So I just want to show you the both ways of doing this with an initial value of 0. So what we are doing now is, instead of individually creating an array for the y value, the x value, and the type value, we are creating one array that essentially hosts elements as using this type. So by default, it can take in all these 4 values, all these 4 fields inside this one array. So that's pretty cool and pretty efficient. So if you come here, just remove this, come here and do array dot push all pivots, and then value is supposed to be a pivot object. So we need to make this pivot object so that this can actually work, right? So just come here, after we have timeframe.swingHigh, you make a pivot object, which is created by calling pivot point.new, which creates a new instance of our object. String length, same thing we've been doing since the start. timeframe_swingHigh. Then if high is true, we'll name this high. Else if it's false, we'll save it as lower high, right? And now we have the pivot object that is collecting all the information we need and storing it inside one object, which is again pretty efficient. So let's do the same thing here. We just need to change this to swing low, change this to higher low, back here to higher low, and then at the end lower low. Get rid of this and one array for them all pivots. Pivot point is what we saw there. And now we don't need to export all these pivots. We can just export one. All these arrays, we can just export one. And just as you can see, you have an error because it's expecting one output but getting multiple. And now we just need to come here and replace this with that, and that, and then yeah. So for I, now we don't actually need to have these values. We don't need to use array get here. We just need to, yeah, we don't need to use so we don't need to use array get there. We just need to make an instance of our type that gets all the elements at once. So we just need to make an instance that gets all the elements. Sorry about that. It gets all the elements at one. Oh, pivots. Yeah, so instead of 3, we just need 1. Yeah. Okay, so pivot point, now it's pivot point dot. Now you can see we can access the elements from here. Dot y dot label text. You can also get this one dot xlog. Right. So this is also going to be pivot point dot label text, and we can just copy that here. And now we've reduced from having 3 arrays. We can actually just remove this, make everything a bit neater. And we can actually get rid of this. We're also not using this right now. As you can see, we introduced it and got rid of it, and you can see the code has completely changed from the first time we started writing this script out. And there we have it, working the same way. We're using less arrays to do the same thing. We don't have labels inside our market structure script, which can be an issue sometimes. We're using functions nicely. This snippet of code here has reduced drastically. So yeah, objects do make your code more usable. They make it easy to read and easy to understand, essentially. Okay, so in this next section, I'll introduce you to methods, first theoretically, and then we'll implement some code to create labels. This label here as a method, and then we'll create trend lines as a method, and then we'll create a function to accumulate what we've learned so far, and then we'll move on to the next concept. So in PineScript, methods are specialized functions that are tied to specific built-in types like arrays, matrices, maps, user-defined types such as the one we have here, or enumerations, which I'll explain in the last part of this video. They are pretty similar to regular functions, but they offer a more concise and convenient syntax for working with these types. You can access this method using dot notation, just like how you'd access fields of a PineScript object. If you ever used Python, you'll recognize this as being similar to how methods are accessed within classes. The cool thing is that PineScript allows you to create your own methods for any built-in or user-defined type. The key difference here is that when defining custom methods, you have to use the method keyword before the function name. And you also need to explicitly define the type of the first parameter in the function signature. I'll show all of this in the code snippet. This first parameter tells PineScript what kind of object the method is associated with. Unlike regular functions, these methods are externally defined in the global scope and are specifically designed to work with the objects you created. So in short, methods in PineScript are a powerful tool for making your code more streamlined and efficient, especially when working with complex data types like arrays and custom objects. So up here, so these are our types, right? Now next we'll create our methods, which are essentially functions that work on our types, and it creates this kind of OOP kind of coding. OOP standing for object-oriented programming, right? So let's create a reusable function, in this case a method, since they are practically the same thing, to handle market structure labels. So you define a method, market structure. So you okay. So you define a method by calling the method keyword at the start, and then structure labels. And then now you have to call out the type. You have to say what type it is, and then the parameter. So this is the parameter similar to how we have. Let me just finish this up so it can all make sense. Then I want to show you the similarity between this and an object, and show you that it's practically the same thing, except one is working on a specific object. So we don't have this parameter, but I think this would make it a bit easier. So I'll add this. We don't have this data type in our, it's highlighted there. So as you can see, this is a function, this is a method. So the difference with a function and a method is that you call the method by stating it's a method at the start, and then the first parameter in a method has to be of a specific type. So in this case, it's the pivot point type that we created, and this is the parameter that is now used to access the pivot point. So I'm going to use this. So I'm going to use this to replace this line of code down here. But first, I need to make the label style parameter, and then now come and input it here. Okay, so let's do that by coming here, add string label style. Then now, just by adding that here, it's essentially inherited by this array, right? So all we need to come and do is come here, add, as you can see, it's already been highlighted as label style. So for these ones, it's okay if it's, I think we can actually have a default style for this, so that you don't have to, constantly reinitialize it. We can have, the default is normally down. So for here, we don't have to do that. But for this one here, I think we now have to, because when it's lower low or higher low is when you set it to label style, label up, right? So here we come and do that, which makes our life a lot easier now that I think about it, because if you come here to style and we eliminate this and have it as label.style, that should actually instantly work. Let's see first before we proceed with, hey, it actually instantly work. You see, that's the cool thing about working with code that is inheriting properties from the start going down, because now if we're working with this, how we started working on this script, we would have to replace that in 4 different places, but all you had to do was add label style here, give it a default value, and add it here, and then come and reduce code here. So it's pretty efficient. Okay, and now we're going to make a method for the trend lines. So let's define that right here, just below this. Just below this here. And we're gonna call it draw trend lines. And this one is going to take in two inputs. So we're going to have the actual current object, and then we're going to have the previous object, because we need 2 points to connect a line to have the trend line, right? That's what you're gonna have. So if not any, so we check if we have a previous value to actually to actually draw the trend line from. And then now we need to determine trend type based on the pivots. So is it an uptrend? So this is how we'll determine whether it's an uptrend. So object.current, object current, I meant, dot. Now we can actually get an attribute from this object, the same we got this XY attribute from the previous one. Object. So if it equals to high, or if the object, the current label, I mean, is equals to a higher low, we can say we're in an uptrend, right? And then we can make another one. And we can have one for line color as well. Now it checks if this is true, it sets the color to green. Else the color is set to red. Now let's create the actual trend line, which is just create a trend line connecting 2 points, the previous and current pivot points, right? It's nothing too complicated. So let's create it here. So lines typically have 4 points. So we get the previous object, its x coordinate for time, right? And then we get its y coordinate, previous, for the y value. Now that's the price value now. And then now we get the second one, object dot current, I meant current dot x. Now that's for the current time and the current price. And there we have it. Nothing too crazy about that. Color now is the line color we defined above. And I'll show you something pretty cool. By defining these methods like this, we create the ability to recall this code. I think I saw an error here. So that's probably just because of indentation. Let's see if that's the case. No. Oh, sorry about that. It's probably this. You can see we don't have that error anymore. And there's something I think I've missed. Let me add some style. Now we'll get this from. No, let's just make this a solid style kind of line, and then xlock is we'll give this a bar, a time. I like using time over a bar index. That's the preference I have. And then now we've created this function that's based on this type system that creates a line between two coordinates on the chart if the previous one exists. So they have to be 2. So we come here and we do if I is greater than start index. So we do that to like kind of enforce that we have a previous pivot and a current pivot to do our manipulation from. And then we now need to retrieve the previous pivot point. And we do that by creating this variable that's recalled. And then we do array get all pivots. We're using _1 here. I -1 to get the previous pivot point, right? And then now we do pivot object. Now here you're going to call the object to calculate the trend lines, and that's how you call the object. So as you can see, I haven't put in two parameters into the method, because you can have the first parameter being this point where we would have, for example, here how we have array.size all pivots underscore 1. We can simply remove that from there and bring it here, because this array.size is an inbuilt method that is essentially of the array type, so it can be used in this unique way and reduce code. So another thing we need to do here is call this other method and have it draw the labels for us, instead of us having to actually draw the labels. And as simply as doing that, it should work. Pivot, no, it's all pivots 1. Yeah, that should actually draw the label. No, it's not. It's actually this. Sorry about it. It is actually pivot objects. And now we need to remove. We can just remove this. We don't need it here, because this functionality has already been called here. And again, we can also do this. We can also do this. Just to show you that the way we've called this method here is something that can be redone, as long as we are using an inbuilt function of a specific type, such as how we were calling these arrays using array size, which an array size is essentially a method that can be applied to the array type. If I was to save this, we should get, yeah, you see, we have trend lines being drawn, green for uptrend and red for downtrend, right? And we have the labels being drawn based on the methods we've created. So what the ability this gives us is, first of all, you can see how modular our code is. We have this specific piece of code creating the data structure that we are mostly using. We have the functions working on that structure. We have this function that we made to identify the pivot points. We're calling it multiple times so we can reuse it. And then we have only this small piece of code interacting with the script on such a grand scale. So it makes debugging this script quite easy. And it also makes it very reusable, because we can decide to actually make this a function, such as, maybe let's call it draw all, and we can decide to make it a function so that we can actually now reuse it with all pivots 1 and all pivots 2. So just come here and give this all pivots, you indent it, and then now you go replacing all pivots 1 with all pivots, right? And now you can come down here and call draw all pivots 1. Then we can call it again to do all pivots 2, right? And we've essentially made that code all pivots 2 and declare. Yep. And we've essentially reused that script, and there you can see we have a greater trend here, and we have a greater downtrend here, greater uptrend there. We have a greater downtrend here, as you can see, and we have these smaller ones based on our different inputs. And just to prove this, if you set this to 10, they would mellow into one thing that you can differentiate the difference, because they're lying on top of each other, right? And that's just the beauty of using methods, objects, and all these data structures. So far, we've introduced methods now, and we've learned how to even make this script even more modular by making a function of this coding, this plotting area, and reuse it. So you can see how easy it is to now reuse code, because we just need to, if we decide to make an input 3 here, we just make swing length 3. We'd come and call this object once, because it's creating everything inside this function once, because it's creating the arrays inside here. And then we'd call this one more time and instantly it's done. You don't have to rewrite any piece of code except the input line, this line, and this line, and we have it. So that's pretty efficient, right? So we're in the last part of this video where I'll briefly introduce you to maps, matrices, and enumerations. I do plan on making a longer video on matrices in the future because they do have a lot to offer and they are not as explored in PineScript yet as they are in other languages such as Python, where they are heavily used for machine learning and dealing with a lot of heavy numerical calculations. So I will do a detailed video on matrices and how they can be applied to PineScript. And for maps and enumerations, I'll just introduce you to them. So a matrix is essentially a two-dimensional array with rows and columns collected in a rectangular format. Like other Pine data structures, all elements must be of the same type, user-defined type, or enumeration type. They reference the elements using two indices, one index for their rows and one for their columns. Matrices, like other data structures, can be initialized with var, varip, or neither. Elements can be retrieved using matrix.get and matrix.set. Using both the matrix.row and matrix.call are used to retrieve one-dimensional structures or arrays from within the matrix. So a matrix is essentially just a two-dimensional array, and this can be really impactful. They have wide implications in many fields. They are heavily used in linear algebra as well as machine learning. And yeah, I'll definitely be exploring this in a more in-depth video. I also plan on exploring whether the availability of matrices in PineScript also opens doors for basic machine learning in PineScript, not the complicated machine learning, but probably basic machine learning can be done using these matrices. So I'll let you know. Maps in PineScript are collections that store data as key value pairs, where each key acts as a unique identifier for its corresponding value. Unlike arrays or matrices, maps are unordered, meaning they do not rely on a sequential index to access information. This is because the key value is unique and can access its value just by referencing the key. So this is very similar to dictionaries in other languages like Python, if you're familiar with them. And to work with maps, PineScript provides a set of built-in functions such as map.put, which adds or updates a value associated with a key, map.get, which retrieves the value linked to a specific key, map.remove, which deletes a key value pair based on the key, and map.clear, which removes all elements from a map. Maps are ideal when you need fast, flexible access to data based on meaningful identifiers rather than numerical indices. So maybe I can just create something really quickly to show you what that means. So let's just create just something very simple, not related to this script we are working on. So this is how you make it. You declare it as var. We're declaring it as var so that it can be declared at the start. Bar index is equal to 0, and we have the key value is going to be a string, right? So that's declaring it. The key value is a string, and the value is the color, right? So let's do if bar index is equal to 0. Now let's call color map, and let's put a value. So that means we're creating one of the values in our map. So for bool situations, we set the color to green, and actually I'm going to use this in the script now that I think about it, to replace the color situation. And we're gonna name this bear, and we're gonna have it as color.red. So that's it. We've created the it needs an initial, yeah. So we've created that map that associates the color green with the key value bool, and associates the color red with the key value bear. So where can we add this? We can add this. Let me just remove it from here. We can add this all the way up here before the method, so that we can have it called here. Yeah, here. So we do color color map dot get, which is what gets the value from the map itself, and bool will essentially, it's essentially an identifier. Bool is essentially an identifier for the color green, and the bear is an identification, is a key identification for the value color dot red. So it's just a way for creating a concise way of retrieving information anywhere in the script that is unique information essentially. And let's just save that and see whether we're actually getting the same results we had before. As you can see, we have the same results we had before. So that's essentially what maps are. They're just a unique way to identify certain elements and call them however you want to call them in the script. And lastly, we have enumerations. So enumerations in PineScript are a special type of data structure used to define a fixed set of predefined distinct values, unlike user-defined types, which can hold multiple fields of various types. Enums are used to represent simple constant options. The primary purpose of enumerations is to enforce strict control over the values used in your script's logic, ensuring that only valid intentional choices are allowed. This is especially useful when limiting input to specific categories such as market states, e.g., bullish, bearish, neutral, indicator types, or trading modes, making your script more reliable, readable, and user-friendly. So again, this is a matter of user-friendliness. So I'm going to explain this using a user input that uses an enumeration to stay consistent throughout the script, essentially. So again, this is how things like enumerations and types are defined. So enum means enumeration, and image choice is the name you've given to this enumeration. So just indent, and then we have SMA, which stands for smooth. So I'm going to do this using just another random example based on. So there we have it. We have the SMA, we have the EMA. We can do WMA, which stands for weighted moving average. Sorry about that. And we can do volume weighted moving average. So volume, and so it just makes an identifier for them as well, a bit similar to maps, but you'll see how you use it to create consistent input in the script, or consistent ways to reference these four values in the script. So we're going to make an input that specifically uses that enumeration called MA type, and when we call it, we have to do input.enum, and its default value is MA choice dot SMA. So that references smooth moving average. And as you'll see, this is just an identifier. The functionality is not working yet. We also have to define the functionality using a switch statement. So ma.length, you have input.int. So you have to use integers for moving averages. Title, ma.length. Then we have ma.source. And then we have input.source. Source is values such as close, open, high, and the source values. There are a couple defined by the TradingView team. Source. And now we move to the functionality where we create the MA result, and we'll do this using something called a switch statement, which acts similarly to a nested if-else type of code. So if-else statements like if then else if it works similarly to that kind of ideology, where you can switch between a couple of inputs you have. And this is the syntax for it. So if ma.choice is SMA, which is smooth moving average, we now create the actual functionality for it to work. And ma length. So you can see you have to choose one or the other. And we made 4 of these. So and I'll show you how this all work on the chart. You'll see why we created these titles here. And EMA, weighted moving average, and then volume weighted moving average. And then now we plot MA result. And let's just give it just a normal color. Let's do orange. And yeah. So if I come here, we have this orange moving average. And if you come here and drop down, you see we have the 4 terms we defined. Smooth moving average, exponential, weighted. But in the script themselves, in the script itself, they're referenced as ma_choice.sma. So that's how they are referenced. So if you choose one or the other, so it just creates a strict way of defining things inside your script, not having to write these things all over and over again. You can just reference them. So yeah, so that's it for this video. We've discussed, I think, probably the major data structures. We've discussed the execution model. We've discussed time series. We've discussed the basic fundamentals of coding, such as identifiers and variables. We've discussed built-in variables and built-in functions. We've discussed user-defined functions. We've discussed arrays, objects, methods, a bit of matrices, maps, and enumerations. So yeah, just practice, and yeah, just practice, and you'll get the intuition of it once you've done enough of that. Thank you, and in the next video we'll be tackling strategy script.